All right, 8th graders, it's time to learn about a concept called tolerance. The first question is your predicted test score is 87% with a tolerance, or in other words, a measure of error of 3%. What range of values do I expect your test score to fall within? So as you look at this question, you're going to start with your goal score, which is 87. And if you have a measure of error of 3%, that means you can be above 3% or below 3% of the goal. So if you're at 87 and you're 3% below that, you would be at 84%. And it would range anywhere from that low value of taking off that 3% to the value where you add the 3%. So we would expect your test score to be somewhere between the 84% up to, and we'll find a better way to write this in a little bit, but up to 90%, because 87% plus the 3% on the high end puts me at 90. So that 3% means I can go below my goal of 87 by 3% or above my 87 by 3%. This whole idea is what we call tolerance. Tolerance is the amount a quantity can vary and still meet the specifications. So I could vary in the above problem by 3%, but still meet the specifications of being a measure of error of 3%. Another way to say this is that it's the amount of error I'm willing to allow or tolerate. That's where the word tolerance comes from, is I can tolerate a certain amount of error. On this test score, I was making a prediction and I was willing to say I could be up to 3% off. 3% low or 3% high. All right, so using this idea of that's how much that I can vary or how much difference I can have and still tolerate, there's 3 ways to write tolerance. The first way is using what we call a double inequality. Recall that inequalities are the greater than sign, the less than sign, greater than or equal to, or less than or equal to. So we're going to use a double one, which means we're going to use 2 of them, 2 inequality signs, and we're going to put a variable in the middle of the lowest and the highest acceptable values. So if we go back to our predicted test score, this answer as a double inequality would look like 84, that's the low value, and then we're going to use a less than or equal to sign. The shortcut on your computer to doing that is the option and then the less than or equal to sign, which is above the comma. So if you hit the option and then the comma key, which has the less than sign on it, you will get the less than or equal to sign. We put our test score in the middle, the actual test score that we get, which we don't know at this point, so we use a variable. And then we're going to do the option, comma key again to do the second less than or equal to sign. There's the double inequality. And we're going to put 90 at the top. So that shows that our test score, whatever we get for T, will fall in between a low score of 84 and a high score of 90. That's called the double inequality. We also have a second way, which is called plus or minus, because when we do this concept of tolerance, we either plus the number or minus the number. So there's a sign called plus or minus. And how you do this is you take your goal value. In our problem, this goal value was 87. And then both things, the allowable tolerance. There is a plus or minus sign if you go to Edit, Special Characters, and then under Math Symbols, it is right here. As you see, it's a plus sign and a minus sign all in one. So if we insert that, we get a plus or minus sign on our paper. And the amount that we can plus or minus is the tolerance number, which in our problem is 3. So that shows us that we will have 87 plus the 3 one time, which is how I got the 90, and 87 minus the 3 a second time, which puts me at 84. The third way, which we will talk not a whole lot about because we haven't done a lot with absolute value yet, but we know that absolute value measures a distance. So we're going to use absolute value to measure a distance, and it's how far is our real value, our variable right now, our t, because we don't know what our test score is, from the goal value. And that has to be less than or equal to tolerance, in this case less than or equal to the 3%. So to do this, we do the absolute value bars, which is above the return key with a shift. So we get a straight absolute value bar. we just go from this definition. Our variable is t, and we're going to subtract because we're measuring the difference or the distance between them. Our goal value is 87. We're going to close our absolute value bar, and now we have to be less than or equal to that tolerance value, which in my problem is 3. So again, it's going to be option, comma, to get the less than or equal to. You're just writing it right now, so you just write the less than or equal to sign, and it's less than or equal to the 3 value. So again, there's 3 ways there, and you can see that once you get this double inequality comes fairly easily because you get the values. Once you get that, the 87 plus or minus 3, and then the 87 goal value goes in the absolute value. The tolerance, the 3 value, goes outside the absolute value by the less than or equal to sign. Moving on to a situation where you might see this tolerance used is when they make sheets, they're supposed to be 107 inches by 86 inches. However, they know they're not going to measure exactly that, so they give them a tolerance of 125 thousandths of an inch. This is the number 1/8. Find the interval to describe both dimensions. Because they used the word interval, we are doing the double inequality. So anytime it asks for an interval, we're doing the double inequality. So remember, to get the low number, you have to take your goal, 107. We want to be at 107, and we're going to subtract off this tolerance. So 107, take away this 1/8 or this 0.125, puts me at 106.875. Again, I got that from subtracting 107 minus that tolerance number. We want that to be less than or equal to the length of our sheet, so that's an L, and we want that to be less than or equal to the high end, which means I can take my goal of 107 and add the tolerance, so 107.125. Now, we also have to do this for the width, so we're going to repeat this same exact computation, only using the width number, which is 86. So we'll take our 86, subtract our tolerance, 85.875, and that's going to be less than or equal to the width of our sheet, which will be less than or equal to the high side of the width, which is 86 plus the 12.125. So we're at 86.125 when we add the values in. Now, because these are a story problem situation and they are measured in inches, it probably is a good idea to put the label inches just after the whole problem. Okay, we probably could have done that up here with the percent as well. Never hurts to put that percent in. Okay, so we'll put the label for inches right behind this value right here. Okay, and I think at this point we will stop with the notes, and that's what you're expected to have filled in when you come to class tomorrow. Thanks, 8th graders.